Alright, stats. If you had any questions on that first 3.1 assignment with Marty, please feel free to ask me any questions. Other than that, we're going back into our 3.1 notes. And we are starting here at standardized values and z-scores. When you standardize a value, you're comparing it only to its mean. And you're comparing it in widths of standard deviation, which every distribution has a standard deviation. So it gives you a good idea of how far away something is from being normal, no matter what the distribution is. Alright, to standardize something, you're going to use this formula. Z equals x minus the mean, which we say x bar, over the standard deviation. And this is called the z-score. The z-score tells you how many standard deviations from the mean an original value falls and in what direction. Observations larger than the mean have positive z-scores, and observations smaller than the mean have negative z-scores. Alright, we are going to find the z-scores for... I erased those. Let's see, I think we did Hunter Howe, Parker, and Brody. Okay, so Hunter's, his height was 71. Then we subtracted the mean, and we rounded that to 68.3. And then we divided this by the standard deviation, which we rounded to 4.3. So make sure you do the subtraction first and hit enter before you start dividing, otherwise it won't work right. So his came out as 0.628. So he is less than 1 standard deviation above the mean. Parker's, she had a height of 62 minus 68.3 divided by 4.3. If you work that out, you get negative 1.465. So that tells us that she is about 1.5 standard deviations below the mean. And Brody's was very similar to Hunter's. Was he 70 minus 68.3 equals divided by 4.3, and that ended up being 0.395. So you can tell quickly that Brody is closer to the mean than Hunter was. Okay, now the whole reason that we standardize scores is so we can compare distributions that are different. So we're going to compare an SAT score with an ACT score, and normally you can't do that. Alright, so we've got Sophia taking the SAT. She had a score of 660 minus the average of 500, and I don't know if these numbers are accurate or not. I think 500s are really low. And then subtract it or divide it by the standard deviation. This is her z-score, so that is 160 divided by 100, so she has a z-score of 1.6. And then Jim took the ACT. He got a 26. The average of the ACT is 18, and then this got cut off. The standard deviation is 6. So 26 minus 18 is 8. So that's 1.3 repeating. So they both had good scores. They were both above average, but Sophia with the SAT was slightly more above average than Jim with the ACT. But without standardizing that, you cannot tell. Okay, that is all for notes today. This assignment in your Google Classroom is your homework for this evening. Ignore the spelling errors. I want you to take a look at number 8. Do number 1 real quick, and then take a look at number 8, because we work this one backwards. You know the z-score is 1.2. Oh, I gotta type. You know the z-score is 1.2. By the way, you can open this in Kami if you want. You just have to click on your puzzle piece, click on Kami, go to Open from Google Classroom, or go Open from Google Drive, and find this assignment. It's easiest if you just type in the name. Alright, so we've got 1.2 equals the x value, which is the data point, and that's what we don't know. But we do know that the mean from number 1 was 80 and the standard deviation was 6. Alright, I'm going to do it this way. So we're dividing that whole thing by 6. So that 75 from number 1 is not in place anymore. We're trying to find what score led us to a 1.2. So then you're going to multiply both sides by 6. So you got 7.2 equals x minus 80. And then obviously add 80 to both sides. So 87.2 equals x. So that is the score that led us to a z-score of 1.2. So it's a working backwards problem and it's not guessing. Alright, if you have any questions, I'll be in office hours at 2:15.